rewrite this as the integral of x multiplied by x squared minus 1 to the power of minus 3. And what we then have there is of the form of f dash x multiplied by f of x to the power of n, where n is not equal to minus 1. And when that's the case, we can raise the power of what we have here, which is the f of x. So just to back up a sec, the f of x would be what we have here, the x squared minus 1. That differentiates to make 2x. 2x is pretty much what we have here. It's off by a factor of 2, which we'll correct for. And that will be our f dash x. So again, f of x differentiates to make what we have there. X squared minus 1 differentiates to make what we have there. Okay, so raise the power of our f of x to the power of n. So in general, for these types of questions, our solution would be of the form of f of x to the power of n plus 1. So then, for what we have here, raise the power of the x squared minus 1 by 1. So this will then become y is equal to x squared minus 1 to the power of minus 2. Differentiate this. So minus 2 comes out, a factor of minus 2 comes out, so we're using the chain rule. The differentiation of the inside would be 2x. And then we have the same term that we had before with its power reduced by 1. So x squared minus 1 reduce the power by 1 to the power of minus 3. And that's just using the chain rule. So this would then be minus 4x times x squared minus 1 to the minus 3. And that's off by a factor of minus 4. So we want it to differentiate to just make 1 times this. We have minus 4 times the same stuff. So then we times the thing we differentiated to begin with by minus a quarter, which will then carry through to the end and cancel out with the minus 4. And then this now differentiates to make what we have here. So this integrates to make this. So answer is then minus a quarter of x squared minus 1 to the power of minus 2 plus c.